In this video, we're going to look at solving systems of equations using elimination. Now, elimination comes in handy when you're looking at a system where it's not easy to isolate one of the variables. And what I mean by that is if you take a look at the variables here and the variables in this equation as well, if you wanted to try and isolate this x, you'd have to subtract the 2y and divide everything by 3. This is going to give you fractions. Same thing with the bottom equation. If you wanted to, let's say, isolate this y, you'd have to subtract the 5x, divide by -4. And so substitution is not really a good method to go about solving this system of equations. So we're going to go ahead and use elimination instead. So the first thing we need to do is we need to multiply one or both equations by whatever numbers are needed to make the coefficients of one of your variables opposites. Now remember, in math terms, opposites means positive and negative. So for example, you want either the coefficient of this x and this x to be opposites, or you want the coefficient of this y and this y to be opposites, whatever that number is, 6 and -6, 2 and -2, 5 and -5. So we're going to do this. Now it doesn't matter which variable you choose. I'm going to take a look and I'm going to say, well, I see that the y's are already opposites of each other. And if I go ahead and I just multiply this equation by 2, what's going to happen when I distribute is that this is going to become a 4, and I've achieved what I need. I will have a positive 4y, and the other equation will have a negative 4y. Now notice, as I wrote the 2, I put this set of parentheses here around the entire equation because I need to multiply the entire equation by that 2. So this equation, once I do this, now becomes 6x plus 4y is equal to -18, and the second equation stays as it is. I haven't touched that one. 5x minus 4y is equal to 7. So I've accomplished step 1 by multiplying the entire first equation by 2, giving me 4y and -4y, two coefficients that are opposites. My next step says add the two equations together. So we're going to draw a line here, and hopefully what you see is going to happen is that when you add these two equations together, the 4y and the -4y are going to cross each other off, which is why we call it elimination. And so we get 11x is equal to -11. In this way, we have essentially eliminated the y from our equation. You should now have one equation in one variable, which you see we've gotten rid of the y and we're left with the x. And so we're going to go ahead and we are going to solve it. So we're going to divide both sides by 11, and we get x is equal to -1. Great. So again, we're halfway done. We have the x coordinate of our answer. Now we need to go ahead and find the y coordinate. So the next thing we need to do is we need to take the value we just found, in this case the x is equal to -1, and we need to plug it into either of our original equations. It doesn't really matter which one you choose. I'm going to choose the first one for this example. So let's go ahead and plug that in. We've got 3 times -1 plus 2y is equal to -9, and so we get -3 plus 2y is equal to -9. Add the 3 to both sides, and we get -6, and so we get y is equal to -3. So now we have our x and we have our y, which takes us back to our last step, which is to write your answer as a coordinate, x comma y. So again, make sure always that you put your x first, your y second, and so we have our answer is -1 comma -3. Again, recall, the reason we're looking for this system is we're looking for the point where these two linear equations, where these two lines intersect. So again, what that means is if we had to graph this -1, -3, this point here would be exactly the point, whatever these lines look like, I'm just going to sketch them in, that would be roughly the point where they intersect. Now, the next thing we need to think about, or the other thing we need to think about really is, in this particular example, we solved the system by turning our y's into opposite coefficients. But could we have done the same if we had wanted to turn our x's into opposite coefficients? So I'm not going to go through the whole thing, but the idea here is if we're looking at our x's, you kind of have to think about it the way you would think about least common denominator. If you want to make 3 and 5 into the same thing, the number they can both become is a 15. So what I'd have to do is I'd have to multiply this entire equation by a 5 and this entire equation by a 3 in order so that both of the x coefficients would be 15, but one of them also has to be negative and one of them has to be positive, so it doesn't really make a difference which one you choose as long as you choose one of them to be negative. That way, when you distribute, we would get negative 15x minus 10y is equal to a positive 45. Remember, you have to distribute all the way across the equation, and we'd get 15x minus 12y is equal to 21, so that when you go ahead and add them together, the x's are going to disappear and you can solve the rest of the equation.